I know we start off our events, special speakers on. Please, everybody stand and pass along.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Thank you very much. Okay, what I'm going to do, I'm going to take our presentation. I'm going to hand it over to Ed immediately so we can get this started, because I know a lot of you were very interested in this subject matter. I don't want to delay it any. So once again, thank you very much for coming.
Thank you, Judith. Good evening, everyone. Good evening, everyone.
Good evening.
All right, great. So, thank you all for coming. Good crowd, okay? We basically filled it out. So with that, I won't hold this up, okay? Tonight, we're really honored, okay, to have a speaker who I think this club owes a good debt of, okay, in terms of week after week, in terms of using our repeater. I want to share a story just very, very quickly. I don't know if anybody was on the repeater tonight, around 5 o'clock, okay? I know Dave was on a little bit afterwards. But all of a sudden, I'm sort of sitting, just sort of listening to the repeater and grabbing something for dinner. And MW0BFY checks into the repeater. John, okay, from Wales. Carl was on the machine as well, too, okay? And it was just really interesting because he checked in, okay? I'm not sure if he knew where the machine was. We had to talk to him about it. But John's comment was the fact that this was his first EchoLink contact. Okay, and I thought, boy, there's a little serendipity. In fact, I told him tonight, okay, that we had Jonathan here as a speaker tonight, and he said, wish you well, okay, from Wales in terms of the presentation as well. So, but, you know, just, you know, if you don't know, in terms of looking at our Monday night net, I mean, we've been averaging anywhere like an average of about 14 people, you know, a high of about 18 people on one night. Okay, we've got anywhere from a third to a half on a given night that use EchoLink to check in. In fact, we call it the near and far net. Okay, so that we really take advantage of the technology in keeping the club together. Our speaker tonight is Jonathan Taylor, K1RFD. Jonathan, you know, we're honored to have him here. He's a member of the CQ Hall of Fame, okay? And he's the co-inventor of patent number 7,188,176, which is the apparatus system and method for maintaining persistent data on a communications network, which is what we use on Monday nights, okay? He's the author of the ARRL book, Voice over Internet Protocol, Internet Linking for Radio Amateurs. He received the ARRL Technical Innovation Award. He's also the recipient of the 2003 Hemvention Special Achievement Award in Dayton. He's named to the CQ Magazine Hall of Fame. He's also a technical advisor for the New England division and a member of the Norwalk Club, okay, as well. So, Mr. EchoLink is a private pilot. He didn't fly down tonight, though. Okay, I sort of gave the bill, okay, but drove down from Stanford. He was, and we're glad to have him here. So without further ado, let me turn the program over to Jonathan Taylor, K1RFD.
Excellent. Well, thank you very much for the intro. I didn't know I had done all those things, so that's good to hear about all that. Hopefully that's accurate. And it's really a pleasure to be here. I have given a presentation about EchoLink to quite a few club groups, and you know, 12, 13, 14 years ago it was happening every couple of months, and has slowed down quite a bit. Things have sort of stabilized. And so I had to dig up a presentation that I had done maybe a year and a half ago and just sort of update it, make sure that it was still relevant. And that's sort of the basis for the discussion tonight. So the topic is Internet Linking for Amateur Radio. I will be discussing EchoLink specifically, but also the other major Internet linking systems, which are also very good. And I should explain, as Ed kind of did, that this was my preferred method of transportation, but it would require him to pick me up at Teterboro, number one, and also for me to drive all the way back home and get in the plane in Danbury, so it didn't really make sense. It would have been great to jump over all the traffic on the Tappan Zee, but you can't always do that. Anyway. So first, sort of a definition of internet voice gateways. These are systems like EchoLink or IRLP that basically let amateur radio stations connect to each other and communicate with each other over the internet. Why would you want to do that? We have amateur radio. But the point here is that this is an enhancement to amateur radio. It's a hybrid system that takes advantage of the RF capabilities of amateur radio and the digital capabilities of the internet. Not a substitute or a simulator for one or the other, but a hybrid of the two. as a way to enhance our ability to serve the public, quite frankly. Examples of this are EchoLink, IRLP, which stands for the Internet Radio Linking Project, the All-Star Link Network, which I'll talk about a little bit. And if you would sort of extend the analogy a little bit, it could include digital systems like DMR and D-Star, which of course have an IP backbone as an option, which is usually implemented between stations. I'm not going to talk too much about that because that's a whole separate topic, which really deserves, you probably have had speakers about digital. But primarily this is about the interconnection between systems which could be analog or digital. And there are many modes, and I'll describe modes that EchoLink supports, and some of these modes are also supported by the other major VoIP systems. First of all, the primary mode here is to be able to connect simplex FM stations to each other over the internet. And this diagram shows just an example of that. The station on the left is tuned to 146.565, a quiet, hopefully, simplex frequency in Connecticut. And the system consists of an FM transceiver and its antenna. It's a very large antenna, by the way. A sound card interface and a personal computer, which is connected to the internet. The station on the right-hand side has identical equipment, tuned to a completely different frequency, and on the other side of the world, Sydney, Australia. So what we've done with this system is we've basically created sort of like a wormhole between a very small coverage area in Connecticut and a very small coverage area on the east coast of Australia, and allowed mobile and portable stations that are in one of those neighborhoods to communicate with mobile and portable stations in the other. Relatively seamlessly, as if they're very similar to a local contact. So that's simplex RF linking. And by the way, one very important point about this is that these two stations don't need to have any pre-arrangement with each other. This is not a link that these two radio clubs set up way in advance and they keep it up and running all the time. This, by virtue of just being on the system, is a very last-minute ad hoc arrangement. As you know, if you've used EchoLink, you can connect to any number of nodes anywhere in the world, any time of day, without any special permission, because everybody's running on each other by virtue of these nodes. Because of this gateway between the two, stations in one side, in this case Danbury, Connecticut, can communicate not only with each other within the repeater's local coverage area, but also, and at the same time, with mobile and portable stations in some other city, in this case Norwalk. So this would be an example of maybe a temporary or a semi-permanent regional repeater linking situation that again requires no special arrangements except for an internet connection. The mode that many of you might be familiar with if you've used EchoLink is what I'd call remote repeater access. Same diagram, except on the left-hand side, instead of RF hardware, we have either a personal computer or a smartphone. Just any computer which has microphone and speakers and has an internet connection and is running the appropriate software, in this case EchoLink. With EchoLink in your pocket or on your PC, you can connect to any of these repeaters or simplex stations that are on the system and be able to communicate them sort of in remote-based style. So remote access to basically FM channels elsewhere. So these are the three major VoIP modes. But it's not limited to single one-to-one station connecting. You can connect many stations together in conference fashion and create sort of a round table. This is an example of three stations that are all repeater nodes that are connected to each other at the same time. Basically, you've created a giant round table consisting of mobile and portable stations that are in range of any of these three repeaters. And because of conferencing software and because of the conference features that are built into some of these VoIP programs, you can extend this to have 5, 10, 15, 20, 100 nodes all connected at once. It's even possible to connect conferences to each other, which magnifies the number of stations that can connect. How does this all work? How does VoIP work? Well, first of all, I should explain that VoIP, if you're not familiar with the term, stands for Voice over Internet Protocol. Internet Protocol, obviously, is the protocol that the Internet uses, or the suite of protocols that the Internet uses. So the general term is usually meant to apply digital voice sent over some kind of a digital network. And it begins with the concept of digital audio. And what we used to call a sound card in a computer, which is now just a sound device usually, if you think about it, it's really just a digital to audio, digital to analog, and analog to digital converter, which happens to operate at audio frequencies, as opposed to RF frequencies. It converts an audio frequency signal into a stream of binary data, and does just the opposite. So that analog data, as long as you sample it at twice the highest frequency of interest, which is called the Nyquist frequency, can be sampled and converted into a number proportional to the instantaneous voltage of the input of the sound card. And by reversing the process at the other end, you're able to form an A to D and D to A conversion. If you were to connect an oscilloscope to a microphone and speakers and run a very slow sweep frequency, and just say the letter A, you would get an envelope that looks like this. Amplitude is on the y-axis, time is on the x-axis. That's the letter A, 350 milliseconds. If we take just a little bit piece of that and zoom in on it, basically magnify it, change the sweep to a much shorter interval, this is how it looks to a sound card. The sound card is looking at the voltage along that envelope. In this case, just, every 100 nanoseconds or so, and is measuring the voltage, instantaneous voltage of the input of the microphone jack, and converting it into a number. Positive number on top, negative number on the bottom. And as you know, once you have a number, you can convert that into a stream of bits. And a stream of bits can be sent over a digital network. So this is the key to how voice becomes digital. So a basic VoIP system consists of two computers that are connected to each other over some kind of digital network, such as the internet. Distance is not much of an issue. Each of these computers has a sound card, so that audio in on one side goes through the network and becomes audio out on the other. And by having a sound card which works in both directions, you have either a full duplex or a semi-duplex connection, where you can literally talk back and forth. Then, for amateur radio operation, all we do is stick a transceiver onto that audio signal. And we've created an RF gateway between these two locations, which can be separated by any distance over a digital connection, such as the internet. You've got a little bit more latency for talking to Australia, but usually you don't notice that, especially for semi-duplex communication like we usually do. So I call this RF for the last mile. We're using each of these communications technologies to their best advantage. We take the internet, which provides us with this reliable, addressable, potentially very long-haul path between our nodes. We take the nodes themselves as the internet to RF gateway, and then we have our mobile and portable stations and repeaters, which give us the reliable stuff over the last mile, even if the public network is down over that last mile. So some popular VoIP systems are EchoLink, which was developed in 2002. There's about 500,000 registered users worldwide. You'll typically see maybe about 5,000 of those on the system at any given time. There's the Internet Radio Linking Project, which continues to grow, although it sort of has stabilized a bit. IRLP is a pure RF system, as I'll show in a minute. And there's also ARRL, which is a module that plugs into a popular PBX software package called Asterisk, and sort of a loose federation of those nodes called All-Star, the All-Star linking system. The nice thing about this is that if you're really geeky, you can do a lot of good stuff with it. It has a lot of customization possibilities. You can build almost anything out of this toolkit. And it has been growing rapidly, and I think rightly so. First, about EchoLink. One characteristic of EchoLink is that it's built entirely by and for amateur radio. It is not an adaptation of some other system. So it's built completely from the ground up, specifically for amateur radio. I designed it originally for compatibility with a system called iLink, which some of you may remember from many years ago. iLink sort of died on the vine and needed somebody to kind of resurrect it. And this is the original motivation behind EchoLink. The first version of EchoLink was released on May 15th of 2002. And if you're wondering what that picture is all about, that's my son Ryan Taylor. And Ryan has the distinction of also having been released in May of 2002. And so they have grown up together, which is kind of hard to believe. He's now a sophomore in high school. More than 500,000 registered users in 162 nations worldwide. and approximately 100 new users come on the EchoLink system every 24 hours. That rate has been relatively stable in the last 15 years. Back in the crazy days like 2003, it was about 170 new users a day. There are two kinds of EchoLink nodes, and going back to the original discussion about the different VoIP modes, these are the modes that it supports. As a PC user, this is what the screen looks like. This is what you probably now would call a legacy Windows application, but it runs on any 32-bit version of Windows, all the way from Windows 95 up to Windows 10. So it is fully compatible with any version of Windows. Basically, it is a single downloadable executable. It's relatively easy to install, and after you run it and your call sign has already been validated and you have a password and so on, this is what you see. It's a list of logged on stations, which can either be shown as a straight list, which can be sorted, or it can be organized in what's called the Explorer view, which organizes it by location, by country. This is based, by the way, strictly on the call sign prefix, as opposed to the actual location. And then some other windows that can appear that show you the status of your connection, if you're connected. So as a PC user, it's relatively easy to use. If you want to connect to somebody, you find their name and call sign in the list, double click on it, and you're connected. And you use the space bar on the keyboard as a push-to-talk switch. The software architecture, however, behind the scenes is a little bit more complex. Again, this is a single downloadable executable for ease of installation, but there's a lot going on behind the scenes. There is a little built-in web server, which can be used for remote control if you have a link up and running. There's a Morse code generator, which produces the Morse ID if you choose to have an ID over your RF link. And various digital signal processing and so on, built-in DTMF decoder. So lots of little pieces all built into a single program. The interfacing, if you're going to set up an RF link, which again is only one of two ways to use EchoLink. If you're going to set up your own RF link like I did here, you connect your PC through some kind of a sound card interface to the transceiver. And the sound card interface will be a very familiar piece of equipment if you're accustomed to digital modes such as PSK31 or RTTY, which is typically an HF. It is quite different than a packet TNC, however. It's actually much simpler than a packet TNC, because all it does is allow the PC to control the push-to-talk switch of the transceiver and optionally detect a signal coming in to the receiver. It also typically provides some kind of level adjustment so that the line output from the PC sound card is at microphone level for the transceiver. And you typically can connect the audio out from the transceiver directly to the line in of the sound card, since the level is about right. So this is the simplest possible interface. It is possible to build your own interface. It is also possible to buy an interface. And these come in a couple different varieties. I actually set up some examples of interfaces on that board, which you can take a look at the end of the talk tonight. There are special purpose linking interfaces that were designed specifically for use with EchoLink. When EchoLink first started to become popular, a couple of hams realized, whoa, people are going to need interfaces and they're not going to want to roll their own necessarily. So several independent entrepreneurs started to produce EchoLink specific interfaces, which consist of a hardware touch tone or DTMF decoder to receive commands over the air, a COS interface to connect to the radio to detect an incoming carrier, and some various audio routing features. However, you can use a generic sound card interface like a rig blaster or a signal link, which is usually used for HF. There's some limitations to using it that way, but it can be done. There's also a class of interfaces which sort of combine the best of both. So you can either use them on HF for PSK, or you can use them on EchoLink. They have capabilities in both directions. Another thing you can do is you can buy one of these, which is the Kenwood TM-V71A, or 71E if you're in Europe. This is one of actually several Kenwood rigs, which by special arrangement with EchoLink have made themselves EchoLink ready, which means that they have the sound card interface built in. The only additional piece of equipment you need is a special cable set from Kenwood, which lets you plug into the back panel and connect to the sound card and the serial port of the PC. And that's the rig that I have set up here. Very simple way to get EchoLink up and running as your own gateway. The server architecture looks like this. One of the misconceptions, by the way, about EchoLink is that when you're in conversation with somebody over EchoLink, you're talking through some kind of a server. That really is not true. When a station connects to another station over EchoLink, that communication is peer-to-peer over the internet. You're sending packets directly through the internet to the other station and not through a server. However, in order to keep the system up and running stably, to enforce security, and to provide a list of the logged on stations, there are a set of what we call addressing servers. These run in the Amazon Web Services cloud. This diagram is not quite accurate. The cloud locations are Northern California, Northern Virginia, and Frankfurt, Germany. There's also a central server, a validation server, which keeps the database of all of the active users and keeps track of logons and does a lot of other administrative things. EchoLink has the concept of positive validation. Really what this is a way of doing is ensuring that every registered user of the system is a duly licensed amateur radio operator. You can imagine that any free internet application is going to attract all kinds of people who may or may not be hams. And one of the big challenges in this project, through its 15-year history actually, has been to come up with efficient and reliable and secure ways of ensuring that each user is, number one, a currently licensed ham, not a formally licensed ham, a currently licensed ham, and is using the call sign that he or she has been assigned by the FCC or by whatever the appropriate national government is. This is a tremendous challenge because there are no standards for this. There isn't any universal digital identification for amateur radio operators, with the possible exception of the ARRL's Logbook of the World. But basically, there isn't any built-in digital identification that makes this easy. And the solution to it is fairly manual, unfortunately, but it's that proof of license and identity is required for every new user. In the United States, it's a little bit easier because the FCC has a public database of call signs. That at least lets us verify that the call sign exists. The next challenge is to prove that it's really you. You can upload or fax a scanned license copy. And of course, now that the FCC has basically eliminated paper licenses, this means you need to log on to the FCC website and download what's called the official copy as a PDF, and then upload that to EchoLink. In other countries, we require just the scanned license copy. Also, in the United States, if your credit card billing address is the same as your FCC mailing address, you can use your credit card to validate yourself for a $1 charge, just to verify the address is the same. Interesting problem, I don't want to digress too much on validation, but an interesting problem is that every single national government around the world has a different format for their license documents. In some countries, the license documents are handwritten. In other countries, they're written in other characters, using other calendars. The calendar in Thailand is, or used to be, based on the emperor's reign. So to figure out when the license is expiring is a little bit of a challenge. But the people who help me validate these licenses, 100 of these a day, are familiar with all this and have seen many of these license copies. Another interesting problem is that there's a few hams around the world over the years who have been so proud of their accomplishment of receiving their amateur radio license that they scan it and post a copy of it on their webpage. To talk for a minute about the Internet Radio Linking Project, IRLP. IRLP has been up and running since 1998, so it's sort of the granddaddy of these VoIP systems. That's quite a long run. One difference between IRLP and EchoLink is that IRLP is a hardware-software package. If you want to set up an IRLP node, you order an interface card, and it comes specifically for use with IRLP with a bootstrap version of the software. It is based on a Linux operating system, as opposed to EchoLink itself, which runs on Windows. It has about 1,700 nodes worldwide, and it is for RF to RF linking only. There is no concept of the PC user connecting to the IRLP network. And this is by design. The designers of IRLP really wanted to make sure that this was an amateur radio project and not a substitute for amateur radio. The PC package looks a little bit like this. And I should explain that the IRLP PC package is designed to connect to the parallel port of the PC. Now, for those of you under the age of 30, you probably have no idea what we're talking about. PCs for many years were built with parallel ports, which are interfaces that were originally designed to connect to printers over a Centronics interface. You can still find a computer with a parallel port at a Hamfest, I'm sure. And you might be able to find a parallel port adapter for other ones. But this is what the basic PC package looks like. The interface board was custom designed for IRLP. It has some of the same characteristics as those EchoLink specially built boards have. They have, status LEDs. They connect to the PC's built-in power supply, the +12, +5, and -12 rails. And they have an ATMF decoder built in, so they're very reliable. And then what you do is you create a special cable that connects to that DP9 connector for whatever kind of radio you have. Radios obviously have different connections, so that's sort of a roll your own. It is possible to purchase cables for this also. The developers of IRLP have realized that it's no longer 1998, and there is a Raspberry Pi version, which is very nice. This little container actually, inside of that is a Raspberry Pi, which if you're not familiar with it, it's a very nice little low-power single-board computer. That's a Wi-Fi adapter plugged into the USB port. And the other thing that's in the package is sort of a miniature version of that board that I just showed you a minute ago, the IRLP interface board. So the combination of the Raspberry Pi and the IRLP interface fit into that black plastic package. And the thing next to it, that wall board, is just a 5-volt micro USB connector. Very nice package. If you really want to go first class, though, you can get one of these, which is it's called the Next Generation, or NG, embedded node, which either comes in a 19-inch rack mount or in a very attractive desktop package. These nodes have some additional capabilities. For example, they can be used as repeater controllers with some additional software. This can be the controller for your repeater, which gives you the additional IRLP capability as well. The software architecture of IRLP is a bit more modular. It is based on a combination of scripts and binaries that run on Linux. It comes with these scripts sort of pre-populated with defaults, but if you're familiar with Bash shell scripting and Unix system administration, you can do a lot of cool things with IRLP. You can customize it quite a bit. You can build scripts against anything. It takes care of logging, it takes care of speech and Morse code signaling. It is based on a VoIP engine called Speak Freely, which was in open source quite a number of years ago. And the IRLP designers decided to build it based on that instead of starting from scratch. For security, it uses PGP, which is a little bit different. This is a security protocol which is distributed, so that when one IRLP node connects to another, they have sort of a handshake saying, who are you? Who are you really? It uses this technique called PGP, or Pretty Good Privacy, which is a public-private key exchange. So every IRLP node has what's called a key ring, which is a list of the public keys of all the other nodes on the system. And by exchanging keys, the two nodes can know that they are legitimate. There's also sort of a hybrid between these two systems, EchoLink and IRLP, known as Echo IRLP, which is very nifty. In fact, I would recommend that if you're going to set up a node today, you go with Echo IRLP, simply because it's more interoperable with today's combination of systems. What it really is an IRLP node that has some additional scripts that allow it to also be an EchoLink node. So it can connect to either an IRLP node or an EchoLink node, one or the other, not both at the same time typically. So it can receive connections from either IRLP or EchoLink. This is great because it means that one node does it all, and once you have this set up, your repeater then can respond to incoming connections from either network. It typically does not cross-link the two systems. It allows either one of them to be used. EchoLink and IRLP were developed quite separately from each other, so they use different protocols. The third system I want to talk about is Asterisk with AppRPT in the All-Star Link Network. And it starts with a description of Asterisk. If you're not familiar with Asterisk, Asterisk is a Linux-based, open-source telephone switch, a PBX. Some of you might remember telephone systems being a box full of relays that might be sitting in the back office of a small business, for example. And it drives all telephones inside the business with the flashing lights and buttons. And of course, there's modern versions of this as well, which use VoIP. Well, Asterisk is one of the modern PBX systems, but its characteristic is that it's open source, which was quite revolutionary when it came out, because telephone systems used to be these literally black boxes that were extremely expensive and proprietary. And along comes Asterisk, and it's all free, free, free. So this is a great system. And somebody realized that Asterisk, being a VoIP system by its very nature, could be extended and become an amateur radio VoIP system. And the thing that does this is a module called ARRL. It's basically an Asterisk application that can be used to connect to repeaters, ARRL. It is used with a special hardware interface, and I have an example of one of them here. The DMK USB radio interface is one option for Asterisk. And the combination of that hardware and that software allows this to be operated as a remote base, as a repeater controller. It can have integrated internet linking, so it can connect to EchoLink or other nodes running on this network. And you can also do crazy stuff like forward and reverse auto patch. Now again, for those of you under the age of 30, you probably have never heard of auto patch. Auto patch was quite the bee's knees, though, in the late 70s. That you could use amateur radio to interconnect with the telephone system and make phone calls, essentially, public phone calls over amateur radio. Clearly, this is sort of a non-starter in today's world. But there are some benefits to having access to the system over the public switch telephone network. This is the ARRL dongle I just showed you. It connects to the USB port of your PC. And optionally, when you set up an ARRL node, you have the option of joining this federation called the All-Star Link Network. It's a loose federation of these ARRL nodes. Each node on the system is assigned a node number, and this is an all RF network. More than 8,000 stations are registered on this network. But you can also say, forget that, I want to roll my own network. I want to set up my own system. I can use these pieces to set up a independent linking system. And one of the things you can use this for is if you're a large club that has several repeaters that need to be linked together, for example, you can link them permanently over the internet using this combination of hardware and software and some custom scripting. So there's lots of possibilities with this. I also want to talk about the mobile computing platform. It wasn't that long ago, it seems. I guess it must have been about 2008, 2009, where I was giving a talk similar to this about VoIP and EchoLink. And somebody pulled this thing out of their pocket and said, can it run on this? I thought, how silly, why would it run on this? You know? But this is a very powerful computer. I heard somebody say this has the power, 100 times the power of the Cray supercomputer from the 1970s. It has radios for GPS, Bluetooth, cellular, Wi-Fi. It supports graphics, multimedia. It has pretty good sound. It has a microphone. It's got a great screen. It's pretty good with battery power. Not bad. It's so funny because my kids, of course, have iPhones, but they never use them as phones. They never make phone calls. They're walking around with computers, literally supercomputers in their pockets. They don't realize it though. So EchoLink for iPhone was born. Basically, it's the same thing as EchoLink for Windows, except it's scaled down to the iPhone. It has a little bit more limited feature set, but it gives you access to the EchoLink network from anywhere in the world where you have an internet connection. And of course, there's an Android edition, which is very similar in function and feature set to EchoLink for iPhone. In fact, EchoLink for Android is more popular in the network than EchoLink for iPhone is. There is also an edition that will run on an iPad. I'll show you a screenshot in a minute. But for the iOS edition, more than 150,000 installs since this came out in January 2010. I'm getting about 450 new installs per week. The Android edition has more than 250,000 installs since 2010 and 100,000 active registered devices. EchoLink for iPad looks like this. It is very similar in function, except it's built around a map paradigm. So you can see the physical location of all the RF nodes that have registered their latitude and longitude with the system. You can zoom in and out of the map, and so on. Now you can see there's a few nodes in suspect locations out here in the North Atlantic, which are probably not oil rigs or cruise ships. Hopefully they're floating. But simply people who entered the Latin lawn incorrectly. There's also a lot of stations off the coast of Africa, which you probably know is at 00. So. And to do the finishing touches for EchoLink for iPad, I was able to set up a very a classic-looking VU meter with a needle that actually moves back and forth. So networking. I'm fully aware that the biggest problem with EchoLink is that it's not firewall friendly. What this means is that as you set up EchoLink at home, you fire it up and it doesn't connect to anything. I'm sure we've all had this experience. I've had this experience. And the reason is, well, first of all, let me explain EchoLink networking. EchoLink uses a protocol called UDP, the User Datagram Protocol, which is the internet protocol which is designed to be used with multimedia, with voice, with video, anything like that, where you can lose a few packets and it's not a big problem. However, UDP itself is not always firewall friendly. And when EchoLink was first designed back in 2002, most of us were still using dial-up, or many of us were. I certainly was. And when you have a dial-up internet connection, you have a full, sort of unfiltered IP address on the internet without any routing going on, at least at your end. So there really weren't any problems with port numbers, and it was just simple to say, okay, let's set a fixed set of port numbers for EchoLink, and that'll be the standard. But the problem is that since that time, almost all of us have gotten to broadband networks which have routers, and those port numbers get translated sometimes by the router. And also you have a situation where a single internet connection is being shared by multiple computers in the same household. We all have that situation. If you have a Wi-Fi network at home, you probably have 3 or 4 or 5 devices, including your smartphone, which are all basically sharing the same internet connection and the same IP address. So when a connection comes in from EchoLink, it doesn't know where to route the incoming connection. It doesn't know which, unless you set it up, it doesn't know which PC is running EchoLink. This is a bit of a problem. The solution to that is to go in and fiddle with your router and set up a rule called port forwarding, which basically says, okay, router, whenever a packet comes in on the EchoLink ports, send it to my EchoLink PC. And that's fine until you sneeze and something changes, right? Or you add another, try to run a second copy of EchoLink that's not behind the same IP address, which is not supported. Should be, but it isn't. One workaround to this, and there are 2 workarounds. One workaround is to work through a mechanism called EchoLink Proxy, which basically takes a piece of the EchoLink software and puts it somewhere else, out of the internet, where this has all been figured out, the forwarding rules. The other thing is to use a relay server. And when I put together the iOS and Android editions of EchoLink, I realized that most of us are going to be running on cellular networks where we can't go in and play around with the routers without being arrested or something. And this is an option for mobile applications which allows you to fairly seamlessly connect to EchoLink with the stipulation that you cannot accept incoming connections. You can only establish outbound connections. And there's a couple of other limitations as well. Anyway, this is what EchoLink Proxy looks like. As I said, it's basically taking the networking stack, or the networking piece of the software, and moving it somewhere else outside of the firewall. Fortunately, some very kind souls have set up quite a few, hundreds now, of publicly available EchoLink proxies. And these are commonly used now for those of us who are behind a restricted firewall or working someplace like at Starbucks where you don't have control over it. The public proxies are listed. There's quite a few now. In fact, the software on the mobile devices can automatically select a proxy if you choose that mode. And the relay servers, as I explained before, are only used by the iOS and Android editions of the software. And they have the limitation that they cannot accept incoming connections, but they can be used for outgoing connections. And I thought that was a reasonable compromise for mobile devices where typically are not accepting incoming connections. We always have the ability to make phone calls instead. So the relay servers are a way of sort of solving this problem in a workaround way, which is very satisfactory for many people. So on the to-do list, the biggest item on the to-do list is to fix that firewall problem. But the biggest problem with that, the code is fairly easy to write, but the difficult part is deploying it. With all these hundreds of thousands of EchoLink users who are not only running EchoLink, but 5 or 6 other software packages developed by other people, they're all using those port numbers. It's extremely difficult to deploy a new version of the software which works differently and will still be able to connect to all the old versions. So there's a big, big compatibility issue that would have to be addressed. It would be a very big project, required a fair amount of manpower, I think, in order to be able to do this smoothly. Someday, but not today. I would like to add automatic proxy selection to the PC version of the software and to offer desktop support for relay servers, for those of us who want it to work the same way as the iPhone does. On the iOS edition, some people have asked me for remote PTT support, so they can use the button on their Bluetooth headset or the clicker on their earbuds to be able to switch in and out of transmit. It's a great idea. Fortunately, that's supported better now in later versions of iOS. You can actually do that. Same thing for Android. Android does have this capability, but it's supported only on a very limited number of devices. It'd be possible to expand that to a lot more. Great for hands-free operation. There is a book on the topic of internet linking published by the ARRL. This is the 2nd edition of VoIP, Internet Linking for Radio Amateurs. But I will say that I'm working on a 3rd edition. So you might want to wait for the 3rd edition to come out. The 3rd edition will be much more up-to-date. This was published a while ago, and there's been some changes in the landscape, and I'd like to be able to update it a bit. There's also other books. This one was written in Japanese, CQ ham radio, voice over internet protocol radio communication. Somebody sent me a copy of this book, and I was really amazed. It looks like a very comprehensive guide to EchoLink for those who speak Japanese, because all the documentation is written in English. So it's great that this has come out. There's also a nifty easy guide to EchoLink, the blue book. Some of you have seen that. So there is some documentation. There's also various ways to support the system. It does cost a fair amount to run these servers in the Amazon cloud. Fortunately, somebody suggested to me years ago that why don't you have a vanity node number system? Instead of being assigned a random node number when you start up, you could request your own number, get a short one, a 4-digit node number. This was a great suggestion because just enough of these have been sold to support all the costs of running the system, which I think is awesome. If you want to do that, you can choose a 4 or 5-digit number for a fee. It's either $15 or $40. And this supports the monthly costs of just keeping the servers running, which is really the main expense there is to it. And that is at least an overview of VoIP and internet linking.